So welcome everybody. We are live casting this event to the world. I sent out about 5,000 messages in the past few days, and I know people from around the world are watching as we speak here today. So this has been a 2-day event. This is day number 2. Very happy to have you all here. My name is Brian Berg. I'm going to be your MC for the morning event here. My background is I'm an IEEE volunteer. I'm part of the Santa Clara Valley section in Silicon Valley, and I'm on the IEEE History Committee, and I'm the Region 6 History Chair, as it's called. Region 6 is the 10 Western states. That's the way the IEEE subdivides the world. So I've worked on over 24 milestones over the years. This is by far the biggest event that I've been part of. So I really want to salute the people from Utah who've made this happen. They've been volunteering for so many different things, so I really want to give a very big thank you to them. So we've got a great set of speakers this morning. We also have some distinguished guests in our audience. First, I want to talk about the impact of this milestone. There's so many different companies that have been impacted directly from the work happening at Utah. Evans and Sutherland Corporation was formed just a few days after both David Evans and Ivan Sutherland arrived here on the campus in 1968. And the companies that came out of that include Silicon Graphics, Adobe, Netscape, Atari, and Pixar. Now, with regard to those companies, all 5 of those companies' names are named on the milestone plaque itself. That shows what a big impact Utah has made on the world. So I want to recognize a few retired faculty and alumni. Now, there's going to be a bunch of people I don't actually name specifically. I want those people to know that they're very much welcomed here. But I know that Rich Riesenfeld and Elaine Cohen are here. Could they stand up, please? And Gordon Romney was the first computer graphics PhD student here. I met him last night. Is Gordon in the audience? Could he stand up, please? And Alan Erdahl developed a graphic interface enabling an oscilloscope to render visual images, amongst many other things. Is Alan here? And on the slide here, Alan and Gordon are both in that photograph from 1968. Also, Fred Park was an early computer rendering, worked on computer renderings of the human face. Fred Park, are you in the audience? So I also want to recognize Robin Forrest. Robin, could you stand, please? Yeah. Yeah. So Robin traveled here from the UK. He was an emeritus professor at the University of East Anglia. He was also a visiting professor at Utah starting in 1969. He visited the university here on at least 10 occasions over the years. And that's pretty amazing to come from the UK over here. So I consider him to perhaps be the University of Utah's ambassador to the UK. That's my own title. But he had also stints at Xerox PARC, Adobe, and Apple, and elsewhere. So he really was one of these guys who just kind of knew everybody, and he kind of spread the word to the UK and elsewhere. Whoops. And Nolan Bushnell, could you stand up, please? Yeah. 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 So Nolan graduated in 1968, and he founded Atari. People are pretty familiar with that company. They had video games and home computers, and probably a lot of people remember Pong. Al Alcorn developed that product for Nolan at Atari. And also, Nolan started Catalyst Technologies, which was a business incubator. And in 1984, the ETAC, one of the companies that came out of the incubator, had an auto navigation system that used dead reckoning with a little screen in your car and a cassette tape with a database to do navigation. 1984, pretty cool. Also, Mark Weber from the Computer History Museum. Could you stand, please? So Mark is out here. He's curatorial director of the Computer History Museum's Internet History Program. And I've did an oral history with him for an earlier IEEE milestone that I worked on. And he also pioneered the concept of web history with help from Sir Tim Berners-Lee, who developed the World Wide Web. So he notes that if you have any materials that are worth preserving, Potentially the Computer History Museum could help you, or other museums or entities around the world, so he's a good contact point for that. His email, mark@webhistory.org, so feel free to contact him. Also, Christine Barton, is she in the audience? Christine. Yeah. So she was an early programmer with Evans and Sutherland, and also is at the New York Institute of Technology, along with Alvia Ray Smith, John Warnock at Catmull, and others. Really important company back in the late 70s that did some very early computer graphics work. And she also went on to work at NBC Television. So if you saw some of the election coverage in the 80s, she was part of the computer graphics that was done for that coverage. Also, Jeffrey Yost from the Charles Babbage Institute. I understand he's in the audience. Could he stand up, please? Anyway, Jeffrey Yost is a director, as I say, of the Charles Babbage Institute at the University of Minnesota. Jacob Gabori, could you stand up, please? So Jacob is at UC Berkeley and also author of a book called Image Objects in Archaeology of Computer Graphics. That was one of two books that I used as a big reference for putting together information for this milestone. I certainly worked with other people on that as well, but Jacob played an important role. He was also one of two expert reviewers for this milestone. The other expert reviewer was Alvia Ray Smith. You'll be hearing a lot from him. Could you stand up, Alvia? Oh, you don't have to. Anyway, he's got an amazing book called A Biography of the Pixel. This is just an outstanding book, and it talks about his firsthand experiences. He's probably the only University of Utah alumni who actually didn't go to the University of Utah. More about Alvia later. Anyway, here's Dan Donahoe. He's the past chair of the IEEE Utah section. Dan heard me give a talk about milestones back in 2020, and used that as an inspiration to realize that Utah needed a milestone, and thought of the University of Utah. We've worked together on this milestone, so he is actually the initiator of why we're all here today. So please welcome Dan to the stage.
Thank you, Brian. I just had a few words on behalf of the Utah section, and our table is back there. Shankar standing there. He's the current chair. So I believe the purpose of any IEEE section is to support our members' careers, those careers that build your communities. So I submitted this milestones proposal in that spirit, and today we gather to celebrate dedication of the first IEEE milestone in Utah. The beloved Western author Louis L'Amour wrote a book entitled Education of a Wandering Man. And he said, a great book begins with an idea, a great life with determination. And our luminaries today began with an idea and enjoyed enviable careers similar to as mentioned. You, the audience, will enjoy the panel sessions today, and each person will tell their stories. Economists often write about business clusters or manufacturing districts to describe how a particular region grows to dominate an industry. As Utah's large defense sector contributes more than 10% of Utah's GDP, several of the leading companies are represented today. So if you look at the 8 tables, that's why we have them all here, and I hope you meet them. I should add that Utah also has .com companies, and we look forward to Texas Instruments semiconductor fab expansion in Lehigh. I would ask, raise your hand if you're an IEEE member so people have an idea of the prevalence and power of IEEE in the technical community. So these are the members, are the technical leaders building Utah's future. There is an IEEE Utah section representative, Shankar, in the corner, so take a moment to meet him. And on behalf of the IEEE Utah section, thank you for making this IEEE milestone with us today. Thank you, Brian.
Great, thanks very much, Dan. I'd like to also now welcome Kathy Hayashi to the stage. I've known Kathy for a few years. She was the past Region 6 director. Actually, pardon me, she's the current Region 6 director for the Western United States. And interesting history of her, she created some of the first graphical layout tools in the semiconductor industry when she was working at Unisys. So she also initiated an IEEE milestone for Qualcomm CDMA technology. Kathy.
Thank you, everybody. And I want to make sure that we thank Dan and Brian for their work in bringing this milestone to the University of Utah. Thank you, Dan and Brian. When Brian approached me about this milestone, I was one of those who was very aware of the importance and the impact of this university. One of my first projects in semiconductor industry was a paper from Dr. David Maddy on the modular design system, and he was here at the University of Utah. We were at Burroughs and Unisys in San Diego, which I know a couple of people were from here yesterday, and we implemented at Burroughs and Unisys a custom hardware description language based on that paper. We actually used it in production to do behavioral synthesis, and also we did timing analysis based on that framework. Further, we took that software and we used this to design the first single chip version of the A series mainframe on a chip, taking the mainframe to the chip. I also attended SIGGRAPH for many, many years, and what we were looking for is to try to understand how we could use computer graphics in the semiconductor industry. I was at SIGGRAPH when I saw Andre and Wally B in the wireframes, and it just inspired me, not only just the technology, but the energy that was in that room. Everyone was going after to see what we could do with computer graphics, and semiconductors was no different. When we were looking at our simulation results as we're designing computer chips, we were looking at them, and remember those printers, the green and white printers? We were very good at ASCII art in order to show what a chip layout looked like. But here we had a whole new set of Apollo computers where we could now do display and we could now do graphics. But some of people resisted and say, well, we have everything that we needed. But I kept thinking about what I saw at SIGGRAPH, and it's like, look, they're trying to use this and use this for various reasons. And I came back with so much energy that we did a graphical layout language. So what that was is a language for layout. And we used it to show graphics on those Apollo computers. And so we used graphics from then on in various aspects of semiconductor design. So what we're here today is to celebrate some of that historical legacy. And so let me talk a little bit about what IEEE is and why this is so important. IEEE is the largest nonprofit that supports technologists around the world. With 6 regions globally, we have members that around the world, for everyone in the world, there is a region for IEEE that supports you. Now, IEEE's overall mission is to advance technology for humanity. And what we're working to inspire is a global community, and we do this in many ways. We have highly cited publications, we have conferences, we have technical standards groups, and we have professional and educational activities. And there are so many that we can't really go into, but please, if you want to know more about IEEE, just go to IEEE.org. Some of the major initiatives that the board is looking at this year is including climate change collections. We have a climatechange.IEEE.org. We're putting a lot of the technical information and making it accessible and a space for people to continue some of those discussions. But to look at IEEE, let's look at it from the numbers. And you can see a lot of the numbers here, and it is an organization with a long history that's very global, volunteers around the world. We have over 400,000 volunteers globally. We've got thousands of conferences. During the pandemic, we were able to take a lot of these conferences to make them hybrid. One of the conferences that I had was slated for San Diego, but in March we transferred it to online, and we had over 3,000 attendees from 70 different countries. So that's some of the things that we could do as an organization to help support our communities and our engineers. We also have, we have the documents, we've got Explore, we've got standards to go back to the standards during the pandemic. I can't bake bread, but I did work with the standards organization to do IP security during those 2 years. And so I encourage you all to go after the standards as well. So we have many different organizations, more committees, and we also have committees on global public policies and also professional ethics. But part of IEEE is that we have, as we discussed, a very rich legacy. And prior to the current IEEE that we know today, it was actually an organization with Thomas Edison, Alexander Graham Bell, who created the Institute of Radio Engineers. And in 1963, IEEE became the Institute of Electrical and Electronics Engineers. However, today it is more widely known as IEEE, and we embrace and are inclusive of all technologists. Yes, it's more than engineers. It includes computer science, machine learning, legal aspects, project management. What we want to do is represent the entire ecosystem to advance technology. There are many benefits to preservation, and engineering history is vital and it's very important. And as the largest nonprofit technological organization, it is IEEE's responsibility to preserve this history. We work to increase understanding of these achievements, to support those in the profession by visibility to others in IEEE and their communities, in both academic areas and industry. And I hope that through these last few days, as I have, I hope you feel the intense pride and community that these days have shown as we look back on our history. And that is what it is all about. Looking at our history and preserving it for others. And I hope that as those today come by that milestone, that they'll be like me in SIGGRAPH in Minnesota, being so inspired, knowing that there's a large technical community and we can be inspired that amazing things happened here and they will happen again and they will happen in our future. As part of the IEEE, we have a History Center, which is the Center for the Public History of Technology. They have a page, if you Google the History Wiki, the site is rich with information. And there's amazing oral history libraries, it's more milestones. You'll see the CDMA milestone that are worked on, and a lot of educational material. And I hope that not only do you reach out to read and see these achievements, but also think about contributing as well. We have people that have done videos here, and we hope that we have more and to increase that library. And that leads us, as part of all of this, understanding who IEEE is, what our mission is, and our importance to all aspects of technology, including the legacy and the history. And an important part of that is the Milestone program. And it honors significant, and I mean significant, technical achievements. And in the past, if you look at the list of those, and some of those are included on the slides, and this milestone that we will be discussing and releasing today, it joins those ranks of the significant achievements recognized by IEEE. I hope that you know that the significance of this, and I want to wish congratulations to everyone that was involved and to everyone that will see this milestone in the future and understand and be inspired by this very significant achievement. Thank you very much.
Thank you, Kathy. So we made a great video about everything that we're talking about today. And you'll almost cry when you see this. I almost did myself. So we're going to go to that right now. So could you please start that video?
When I was a young assistant professor and starting the Scientific Computing and Imaging Institute, I got to meet our famous graphics alumni, and I asked them all, how in the world did you create this amazing graphics phenomena, in Salt Lake City back in the 1960s and 70s? And they all said the same thing. It was about people, getting the very best people who could collaborate together and putting the best computing resources possible in the hands of these people and then getting out of their way. And these amazing people who were recruited from around the world made fundamental contributions in rendering, shading, animation, visualization, and virtual reality, and really went on to change the world. I think a good place to start the story is in the early 1960s, when Ivan Sutherland created Sketchpad as part of his PhD dissertation at MIT. Sketchpad really set the stage for future research in the nascent fields of human-computer interaction, computer-aided design, and computer graphics. In 1965, David Evans was recruited to Utah from Berkeley by President James Fletcher to create a computer science program at the University of Utah. Alan Kay tells the story that when he met David Evans for the first time, he described seeing a stack of brown-covered documents on Dave's desk, one of which Dave handed to Alan saying, "Take this and read it." The title of the document, Sketchpad, a man-machine graphical communication system. It was required reading for everyone. In the early days of computer graphics, figuring out what should not be seen in the background was more difficult than what could be seen in the foreground. Enter John Warnock, who in 1968 created a hidden surface algorithm to solve this problem. In 1968, Ivan Sutherland joined the faculty at the University of Utah, and the Evans and Sutherland Company was founded. As Ivan tells the story, the reason ENS ended up in Utah instead of Boston was because of Joy Evans' reasoning. She said, "Dave, we have 7 children and Ivan only has 2. It would be much easier for Ivan to move to Salt Lake than for us to move to Boston." And thus, Ivan moved to Utah. In 1972, in Ivan's computer graphics class, students participated in one of the earliest attempts at digitizing a physical object, a Volkswagen Beetle. The car was originally owned by graduate student Henry Garreau, who sold it to Ivan's wife, Marcia. As Robert McDermott tells the story, he and Jim Clark were taller, so they digitized the higher points of the car, and Boi Tong Fong and Raphael Ram were shorter, so they measured the lower sections. In 1974, things became animated. Ed Catmull digitized his own hand and created a fully shaded 3-dimensional computer animation. Fellow graduate student Fred Park worked with Ed on the hand animation and also created a 3-dimensional animated face. The French Connection. In the early 1970s, Henri Garreau and Boi Toi Fong would move to Utah from France and create improved models for lighting and shading. Henri used his wife Sylvie as a model by drawing polygons on her face and created what is now known as Garreau shading. The year Henri graduated, Boi Toi Fong came from Paris and became a graduate student at Utah, building upon Henri's model, and also created a more realistic lighting model based upon ambient diffusion and specular components. Both Garreau shading and Fong lighting are still taught in computer graphics classes today. We now move to the mid-1970s to the creation of the Utah Teapot, which became one of the most iconic images in computer graphics. Graduate student Martin Newell modeled the teapot after one his wife Sandra purchased from the ZCMI department store. Fellow graduate student Jim Blinn thought that Martin's teapot would be a great graphics test subject, so started experimenting with it, finding an aesthetic scaling. It became a common benchmark model for computer graphics and is likely the most famous and widely distributed computer graphics image in the history of the medium. In the mid-1970s, we had further innovation in computer-aided geometric design and also virtual reality with Jim Clark's freeform B-spline surfaces using a head-mounted display and Henry Fuchs's automatic sensing of 3-dimensional surface points. Between 1975 and 1978, Jim Kajia, Ivan Sutherland, and Ed Cheadle built the Evans and Sutherland Video Frame Buffer, which helped make possible modern computer graphics. During this time, Jim Blinn, when not playing his trombone, would create realistic specular lighting models, bump mapping, and environment mapping, which provided more realistic graphic possibilities. In the short span of 15 years, researchers at the University of Utah made fundamental contributions to computer graphics processing, from lines to surfaces, from wireframes to rendering, from static images to dynamic animations, from simple shapes to realistic computer graphics. The computer graphics world acknowledges and today celebrates that David Evans, Ivan Sutherland, John Warnock, Alan Kay, Henri Garreau, Boi Toi Fong, Ed Catmull, Fred Park, Jim Clark, Martin Newell, Ron Resch, Henry Fuchs, Nolan Bushnell, Rich Riesenfeld, Elaine Cohen, Jim Blinn, and Jim Kajia, among several others, helped change the world.
Wow. That video is the essence of the words of the citation on this bronze plaque that we're talking about today. Everything in that. It's just so many of the words you heard, some of the techniques are in those words. So words really matter.